My review ideas are very classical. I go fast because it's not a new material anymore, and your job is to make it smart. If you know it, if it's too easy, too hard, and that's how you know your own feedback about the material. If you go to modules, you guys, let's start. If you go to modules, find the module that has very important title. It's called Exam Keys and Materials. Here they are. Questions, people? Phones off. Thank you. Find the exam 2 review. This one is provided by your coordinator, so I'm going to follow this one. It looks like that. And we're going to do lots of problems from this review. My YouTube videos have lots of solutions for these problems. So you should have lots of stuff and resources to review. And last time we did a problem about the cup of the coffee. It's actually there as well. It's the last problem on the review. The last problem, 32, is on the review. So I'll make sure to write down 32. Now we're moving back to the material we learned. We learned about critical points. Remember, there was quiz asking you to analyze the function. And it's exactly going to be on the test, either one huge question or mini questions. Analyzing the function means finding derivative, finding when it's increasing, decreasing, find local minimum, local maximum, find when the second derivative, find when the second derivative was positive, negative, concave up, concave down, find points of inflections, if any. We're going to have all of this on a test next week. But for now, let's start slowly with relative extrema. Relative is a synonym of local. Extreme values means minimum or maximum. Here's the function for you. When you see these words, relative extreme values, and so on, minimum, maximum, you know how to start. You need to find the derivative of the function. And that's why we always push students to be very good at that, finding derivatives of the function. Minus 12x squared plus 6x plus 36. That's the most important step. If you mess this one up, kind of everything will be wrong. Then you set it equal to 0 in D and E. You find zeros in D and E points. Both will give you potential maximum or minimum. Because remember, if there is a hill, this is where derivative is 0. Or if there is a cusp, this is where derivative is D and E. D and E. I can see your hand. Just a second. Yes.
Is it minus 6x or is it plus?
Minus, thank you. Yeah, minus 6x. So catch the mistakes because I want to go fast. Now remember that here derivative does not exist, and that's why we need to check both. Now there's no D and E for the quadratic functions, so we only need to solve minus 12x squared minus 6x plus 36 equals to 0. Very fast, using quadratic formula. In this case, I would divide by 6 because it will make it easier. Minus 2x squared minus x plus 6 equals to 0. Either you know how to do it or use quadratic formula, and it gives you two solutions. x1 is 3/2, x2 is minus 2. I just have it in my solutions, but you know how to solve quadratic equations. If you don't, watch my YouTube video. I do have that actually. What do you do now? First derivative sine line test. So, step 2. Sine line for the first derivative. Looks like that. Sine line, the first derivative is here, signed. I put the first derivative in the box right away because that will help me in the future. Here it is. I put my critical points, which should be in the domain, they are, on the sine line in order, minus 2 and 3/2. And then I choose a test point on each interval, any point you like. Plug it into your first derivative. That's why it's over here, to remind you where to plug. Well, between negative 2 and 3/2, 0 is a good one to plug. I don't care about the number. I just need to know the sign. When I plug 0, it gives me plus 36. So this one is plus. Minus a million. I like big numbers, so something huge and negative, and then something huge and positive on each side. I'm going back to my quadratic equation. If something huge in and negative, square makes it huge and positive. Negative 12 makes it huge and negative. This one is positive, but negative is 2 negative, so this should be negative, I think. Let me see. Oh yeah, it matches. And then the other way around, or not, with huge and positive, 3/2. Still negative. What does it mean? It means the original function f is decreasing. Let me write down. F is decreasing on -infinity to -2, do not include intervals, and from 3/2 and plus infinity. The hand goes down when you put the pencil on the graph of the function. And the original function is increasing from -2 and 3/2. They did not ask about this question, but on the exam we will. So make sure you remember how to do that. And now this visual idea is really good here, because when something is going down and then goes up, at the bottom there is local minimum. Local minimum. When something is going up and going down, visually you can see this is local maximum. And you can have many or infinitely many. Like with sine and cosine, you have infinitely many ups and downs. So, x equals -2 gives you local minimum. But how small is this minimum is? Where should I plug -2 to find that answer? The original, good job. Plug, so that's going to be step number 3. Plug into original f to find how deep this pit is going down. F of -2 is, calculate, and it gives you -40. So the point in x, y notation is -2 and -40. This is local minimum. Same situation happens with x equals, so I'll do like a dot and a dot. X equals 3/2 gives you local maximum, but how high does it go? Plug into the original. F of 3/2 equals, goes, you calculate 1/83/4. So the point answer will be 3/2, 1, 8, 3, and 4. That is local maximum. This gives you full credit. Can you do that? So don't forget your calculator, definitely. You will at least need it to plug things into your function or into your derivative. Let me check if I'm recording. Yes, good. Questions about this? Local maximum, local minimum, increasing, decreasing comes from the first derivative test. So that is already lots of work. You can imagine 2-3 problems like this. Now, how about concavity? Let's do one more example. This example from the review is number 1. Number 1 from the review. Now I'm jumping to number 5. Number 5. Number 5, f of x is 2x cubed over 3 minus x squared plus x over 2. Like so. List all the points at which any extrema occur and classify them. Extrema, extreme values. You start with the first derivative. Solution. F prime is, first find a derivative. Do you all see that's going to be 2x squared? Simplifying fast. 3 goes down, 3 cancels out with 1/3. X to the second. Maybe I should write it down. It's going to be times 3x squared over 3, cancels, minus 2x plus 1/2. Review differentiation, that's important. Set equals 0 and d and e. Remember, if you have a fraction, d and e might show up, but not in this case. It's still a quadratic function. 2x squared minus 2x plus 1/2 equals to 0. Quadratic formula, or you can also simplify it by dividing by 2. I actually don't know the solution of this one. Who wants to calculate really fast? I would divide by 2, to be honest. X squared minus x plus 1/4 equals to 0. You can do quadratic formula if you want, but does anyone calculate it? Minus b, so it's minus 1 plus minus, no, interesting. Square root b, yeah, okay. 1 plus minus square root of 1, so it's going to be minus 4ac all over 2. Oh, it's just one root, 1/2. Did you get 1/2? Did anyone get 1/2? Yeah?
Yeah.
Okay, good job. So, sometimes quadratic functions can have only one root or no roots. Quick reminder why. The parabola can be typical one, then you have two roots. Lift it up and touching x-axis only here, then one root. Or lift it up and no roots at all. So, depends. In this case, it's only one root. Sine line for the derivative. Put 1/2 here. Check the sign of the derivative at the testing points. For example, at 0, I have plus, because 1/2. And then at million, I also have plus. Do you all agree? Check. If I plug huge numbers, 2x squared is huge, minus 2 something is huge, but not as big as 2x squared, plus 1/2 gives you plus positive. So,
Use my head for 0 and 1.
the original function is increasing and then keep increasing. F is increasing from minus infinity to 1/2, and then from 1/2 to plus infinity. Your book merges the answers, which I don't like, but it's fine. On the exam, I will not judge you if you merge, but actually you're not supposed to, because at 1/2 your derivative is neither plus and not minus. It's 0 there, so you're not supposed to merge. Function is increasing everywhere. So function has any maximum or minimum? No, it's just infinitely going up. No max or minimum, at least from minus infinity to infinity. The moment you cut it somehow, it will have. So that is the answer for the question number 1. And then question number 2, there were 2 questions. Question number 1 was to find local extreme values. Question number 2 actually asks to list all the inflection points. List all poi. Poi are points of inflections or inflection points. Points of inflections or inflection points. Inflection points. And that is a great review right now. To do it, this comes from the second derivative. Second derivative should be found first. So let's find second derivative. Luckily, we're working with a polynomial, so there is no quotient rule happening, product rule happening. 2x squared gives you 4x minus 2. 4x minus 2. Like so.
And we just need to find where it equals 0, right?
When does it equal 0 in D and E again?
Isn't it supposed to be 4x minus 1?
Let me see. 4x minus, no, this one.
Oh, okay.
Yeah, Thank you. So let me write down, like so. Second derivative comes from here. Put this in the box. Well, x gives you 2. That is the only point we have. So maybe that will be the point. 1/2. Yeah, thank you. 1/2. So maybe that will be the point we need. Let's see. You draw a sine line, but now for the second derivative, you put this 1/2 on a second derivative sine line and choose test points to plug them into your second derivative. If I plug 0, it's negative. If I plug infinity, it's, well, not infinity, a million, it's positive. So the original function is not going down, going up. What does it do instead?
Switching concavity.
Concave down and concave up. Remember, if your second derivative, f prime prime, is negative, the original function is said concave down. Derivative versus original. So this is concave down. But if the second derivative is positive, the original function is smiling. That is concave up. Moreover, if it is smiling, this bottom, which is like a tongue, is your minimum. But if it's set, the nose is your maximum. That's nice, fun way to memorize. So, if 1/2 is in the domain, and it is, since x equals 1/2 is in the domain, and it changed the concavity. So it changes the sign of the second derivative. That means changing concavity. Concavity. IT. Thank you. Yes, concavity. Then x equals 1/2 is point of reflection. Poi. Yes.
Sorry, can you explain how to concave down?
Yes. So I can also write down. I probably should. Good point. So if the second derivative, so the second derivative is negative. How do we know it's negative? I chose point 0, plugged 0 into here. 0 minus 2 is minus 2, which is negative. If second derivative is negative, the original function f in blue is concave down. So like upside down cup.
Wait, so why is it positive on this?
And on the right side, I chose, like say, 100. I plug 100 over here. 100 times 4 minus 2 is plus, right? So derivative is positive. Then the original function is concave up, like a normal cup. Make sense? Concave down when the second derivative is negative, and concave up when the second derivative is positive. It's kind of the other way around if you think about it. Up versus down. And let's write it down. Good job for pointing this out. So let's see. Concave up. F is concave up on, not at, on the interval from 1/2 to plus infinity, and concave down from minus infinity to 1/2. Did I answer your question? Ask me. Maybe something else? What do you think? Concave up, concave down. So increasing when the first derivative is positive. Decreasing when the first derivative is negative. Concave up when the second derivative is positive. Concave down when the second derivative is negative. Make sense? So review that. That is important as well. Now, global extreme values. This was local. Let's go to global. Global. Mean, max. Usually we ask you to find global mean max on the interval. It's not necessary to have an interval, but we just teach it this way.
Wouldn't that be local?
Now, on the interval will be global. Global, sometimes also called absolute. Global or absolute. Absolute. Absolute actually is a more popular word, to be honest. Absolute global extreme values, min max. For example, number 6. Number 6 gives us a function and requires quotient. So you have to review product rule and quotient rule, including logarithmic functions multiplied by exponential one. It is there. And then they ask you, find global mean and max. But this function is infinite, so they made a cut of the domain on 1 to 5. Moreover, this function does not exist at 0, but the cut was made after 0. So it's interesting that at 0 it doesn't exist, but they decide not to completely ignore it, and they say, oh, we just want to be from here, from 1 to 5. This is where we're going to make a list, remember? Global mean maximum on the interval is where we're creating a list of all critical points and endpoints. Critical points and endpoints. Solution, you always start with the same thing. You find the derivative. In this case, it's quotient rule. Try to do quotient rule faster than me. 5x squared, square the denominator. Differentiate the top, that's 2x. Copy 5x minus copy x squared plus 4. Differentiate the bottom, which is 5. Right. Simplify. 25 x squared, not necessary, but why not? Then it's going to be 5 times 2, 10x squared minus x squared minus 1, which is 2 very nice. Yes.
Minus 5 squared.
5. Let's see. Oh yes, 5. This is 5 squared times x squared. Make sense?
This one going and then
Oh, x squared. 5 times 10 x squared minus 5. Perfect. Good job. This one is also distributed. So it's going to be 10x squared minus 5x squared, which is 5x squared minus 20. Good catch. This is the final version of my derivative. Put it in the box. We will need it. You know that.
Couldn't you divide everything by 5?
Yes, I would do that right now. But my tablet is running slow. That's fine. Let me close this. We could divide everything by 5. That will make life easier. It's going to be x squared minus 4 over 5x squared. Set it equal to 0 to find critical points. Critical points are where your derivative is 0 and d. When you're working with a fraction, d comes from the denominator. So you set the numerator to be 0 and denominator to be 0. That gives you D and E points. D and E points. Solve while I'm restarting. What 3 points do you get? I have 3 points.
0 and then plus the negative.
Yeah, exactly. And now you should ask yourself, do you include all of them or not? Because critical points should be in the domain. So let's do it. X squared minus 4 gives you 0. X gives you plus minus 2. These might not be critical points. Still a question, because we need to check they are on the interval we are allowed to work on. And also 5x squared equals to 0. X gives you plus or minus 0. This is also a question. So I'm going to the domain. The domain was restricted to 1 to 5 domain. Very interesting. They could actually do it from 1 to 1.5. Then there will be no critical points at all. So it's actually a scientist's choice how large the domain should be. So yes to this, no to the 0. Because 2 in actually minus 2 is not. Minus 2 should be kicked out as well. So let me list. X equals 2 is fine, x equals minus 2, and x equals 0 are not fine. Not in the domain. So list just shrinked to 1 point out of 3, plus 2 endpoints. Let's do step 1. Step 2, kick out extras. That's what we call extras. Again, sine and cosine have infinitely many critical points, and you're supposed to kick out all the extras. Step 3, make a list. A list will include your critical points, only one in this case. This is a critical point. And endpoints, 1 and 5. This is your A and this is your B. Now you're plugging into the original function. You can write it down again, but it's kind of a waste of time, so I usually don't do it. X squared plus 4 over 5x. And you plug it in, and guess what you do? You choose the winner. This biggest value output gives you the maximum, the smallest one gives you the minimum. F at 2 gives you something, F at 1 gives you something, and F at 5 gives you something. At 1 is easy. 5 over 5 is just 1. What is happening at 2? At 2 is 4/5. And at 5, it's 29 over 25. So who gives you the maximum? 5, because that one is greater than 1. And from the whole list, that's going to be the biggest one. That is your global maximum. Happening at 5 and is 29 over 25 high. What is the minimum?
2.
2. That is your global minimum, like so. So the answer will be x comma y, which is 2,4 and 5,2925. This is your global minimum, and then this is your global maximum on the given interval. If the interval is increased, everything should be recalculated from the scratch. Yes?
Isn't the denominator of the equation 5x squared?
Oh yeah, true. 5. No, original one is not. Original one was like so.
Oh, so the original.
And then we square it due to the quotient rule.
Okay.
And then I simplified like so. It was 25 times x squared, and I cancel out 5 over here.
It just all worked out.
4 and 5. So it's just coincidence that it looks the same, almost the same. So review this. This have to be on the test. We usually put it on the final as well, but we don't have final in this class, so you guys are lucky. But second exam, yes, we're putting it there. Questions? Not too bad. Can you do it? It feels like a lot of material, but if you practice, which you should do, since I'm moving the exam a lot.
I've done this enough times that I think
Right?
I can just do it by.
Number 7. Do you remember what does it mean to have this weird phrase? I'll just write it down. Do you remember this idea? Some people got very confused about this. What does it mean to maximize r, which is 3x squared minus y squared, subject to this weird phrase you saw, subject to 2x plus y equals 32.
So it's optimization.
Good job if you remember. What does it mean subject to? Who remembers what kind of chapter is this even? Which one?
I don't know what the chapter is.
Optimization, yeah.
Like the 2x plus y equals restriction.
Yeah, exactly. Constraints, yeah, restrictions. Good job. So you guys remember the box problem, the fence problem, the business problem. We always build objective, so this is optimization problem, optimization chapter. We build objective function, OF, and then constraints or restrictions, constraints. For example, objective function was the cost of the materials to build the fence. Constraints were, well, if you add 2 sides of x and 1 side of y, it should be not more than $32, or it was a size of the perimeter, or something like that. Restrictions. So this is part of the optimization chapter. We know that they want us to maximize r. Maximizing means finding derivatives that equal 0, sign line. But it has 2 variables, x and y. In Calculus 3, we teach you how to deal with multivariable derivatives. But before that, there is a way to avoid doing that. You use this solution. You use the second equation of the model, which has a function which is called objective function, which we need to optimize, and constraints 2x plus y equals 32. You use this second equation to solve for one of the variables and plug it into your objective function to make it dependable only on one variable. Many people are noting that is a very good sign. I'm very happy about that. Other people doing fine? Computers, laptops, and phone people? How are you feeling about this? If you fail this exam, I'll kick your ass. This is the best exam from all 3. Like, if you fail this one, I don't know, I'll be very upset. I'll be grading and I'll be very upset. You will owe me some ice cream if you fail. So, come on. So which variable you choose to solve for? Just any is fine, but y looks easy. Good job. Y looks like we're gonna avoid some fractions, so it's good. Plug it into r. R will be 3x squared minus y squared, which is 32 minus 2x squared. Some simplification should be happening here. Remember, you cannot just put square everywhere. You use the formula, which is called square of sum or difference formula. 32 squared, square the first term, plus or minus double product of the other 2 terms, plus square the second term. That is the formula. You don't just put 2 everywhere. That is not correct. So simplify, get some nice equation. I don't actually have any solution for this, so let's do that. Don't forget to distribute the negative sign everywhere. So I will have 3x squared minus 4x squared. I guess should be minus x squared. And then I will have minus 32 squared, whatever this number is. And then minus plus 2 times 2 and 4 times 32. 12 and 8x. I think I'm right, but you should check. That's quadratic equation, so now we know how to do.
Wait, where'd 2x squared go?
X squared is this guy. 3x squared minus 4x squared.
Okay.
I think, unless I messed up. Now you know what to do. Set it equal to 0 and solve for the variables. I do have solutions for that. If you solve the quadratic equation, it gives you 64 and some kind of other number, I guess. Maybe, oh, the other number probably is negative. So who knows what is the other number? And the negative one, oh, yes.
I don't know if they answered, but I actually have a question. Can you explain that first line after the third platform?
Yeah. This one?
Yeah. Oh, no, the one under it.
Under this one.
Yeah.
Let's do it slowly. So 3x squared is the same. I just copy that one. Minus, and then I use this formula. A minus B squared equals square of the first one minus 2ab plus square of the second one. Lecture 0, I always review this formula because I know we're going to use it quite a lot. So check my very first lecture. 32 squared, here it is, minus 2, part of the formula, a times b plus b squared. So that's what I did. Now you have to distribute negative sign and collect the terms. Yeah, thank you for asking. That was good. Yeah. So did anyone solve while I was talking? 64 and what? Or just 64?
I got 8.5 something, and then the other one is 119.
Yeah, that's what I got.
I think you. Oh, did you? When you
Did we ever differentiated it? Duh. You're supposed to differentiate it. Bless you. See, that's true. It's not as hard as it looks supposed to be. This is your original function, which is r. We just plugged in something. Step 2, we did it so that we could differentiate it. Yes, that's why it's easier than it should be. Step 1, solve for the variable, plug it into your objective function. Step 2, differentiate. Derivative of r will be minus 2x. 32 squared, we don't even care what it is, gives you 0, plus 1, 2, 8. Now it's 64. X is 64, only one answer. Usually, if you have several answers, one of them is negative, radius cannot be negative, volume cannot be negative, side of the triangle cannot be negative. So you kick those out if it's a real life problem. Here, you don't even care because it's just 64. So it's the only value. That should be the answer. But actually, you can justify it by drawing a second derivative. Signed line, put it in 64. Come on, baby, don't die. Why are you so needy today?
And for 0, you got all this stuff.
Right? I kind of also noticed. It kind of depends on the weather, I think. Okay, you can plug testing points and check the signs. If I plug 0 into your derivative, gives me plus. If I plug a million minus original function r, increasing, decreasing, so this is your local maximum, or global in this case. So, answer is x equals 64 will give you global maximum. How about y? People who are talking, how about you? Do you know what y is? Wait, you guys are talking. What do you think y is?
It's negative.
Just a second, let me demonstrate. Who is talking? What do you think y is?
Well,
How do you find it?
let's plug it back into
Where?
R1, right? Or no, the original one.
The original number 2.
Yeah.
Equation number 2, good job.
Y equals 32 minus 2x.
Exactly, good job. 32 minus 2x is 32 minus 2 times 64. That gives me minus 96. And finally, R. How to find R? Plug those two into the original. Or you can plug in the one with only x in, and it gives you 3072, and that is your maximum. Maximum, because the derivative was positive and then negative. So they asked us to maximize, and we found the maximum. And kind of we assumed it should be plus minus, so it matched the idea that it is indeed maximum. Happening at two variables, x and y. So R here is two-dimensional, depends. R here is three-dimensional, depends on input of x and y. R is the function of two variables, x and y. That's the idea. So this is the first case. We're slowly preparing you for 3 dimensions. That's the idea. Can you do that? And don't be afraid of the idea subject to. However, if you check problems number, check at home, and I have lots of videos on those box problems and so on, window problems, cutting the squares, fencing problems. Number 8, 9, 10, 11. Check the quiz. We just had quiz. Remember it was there. All those problems, I just choose one of them and put them on a test. It's usually the shortest one. Remember the, So the fencing problems are very nice one. The box problem with cutted corners, that was also nice, cutting corners. And so on. So review this, I have lots of videos on this. One more idea of application problems were used in related rates, and we just had it recently, related rates. Wow, it's just getting worse and worse. Related rates. This one, check problem number 16. I will not repeat it because we just had it in the quiz, and I'm posting all the keys. Remember the balloon problems. The balloon is increasing, and we give you volume. We don't even ask you to memorize the formula. And then, when you differentiate this formula that has two variables in it, you use implicit differentiation, which we are going to review right now. dv with respect to third variable t equals 4 third pi 2r dr dt. So this will go to the test, either the balloon problem or circle problem, and there are more problems on the review, which are 17, 18, and 19. 17, 18, and 19. Check this. I also just gonna choose one and just put it there. Related rates problems. And then we either gonna give you, we always give you one rate and time of that rate. So we say dv over dt is given. Find another rate when r is 5, or vice versa. So those kind of things. Related rates, when something is changing together with something else, and they both related with respect to the third variable. Last 10 minutes, not so many things to do. They are only left implicit differentiation. Implicit differentiation. This is the one you have to practice. I can show you thousands of implicit differentiation examples, and I do show you in my YouTube videos. I have so many examples that you should work on. But if you don't do them, you just watch the video and know like this, you're gonna fail the test. Because your hand should know how to do it. For example, number 12. And the cool thing is that you have to be, not have to, but you can learn how to be fast when you do that. Y squared minus 7 equals 8x y minus 3x plus 2y. Probably should just restart the computer. That's probably the reason. Something is updating. I'm pretty sure. Do you remember this? That actually reviews product rule and everything. You treat as y dependent variable, so y derivative will be y prime, but x is independent variable, so x derivative is just 1. 4x squared gives you 8x, y gives you y prime, 7 gives you 0. 8x times y is the product rule. 8x gives you 8. Copy y plus copy 8x, differentiate y. Derivative of y is y prime. Y prime. Y prime. Minus 3 plus 2, 2y, y prime. Such a pain. This is such a pain. Next idea. Locate y primes and pieces glued to them and move them to one side. Factor out right away if you want to be fast. Y prime factored. Or you can even do the answer follows right away if you want to know. Whatever you're going to factor will go to the denominator in brackets. 1 minus 8x. 8x. And minus 2. And I can explain steps how did it happen. And whatever is just messy stuff holding like this on the right hand side will have plus sign. This is my right hand side, minus 3, and minus 8x. This side was moved to the right, x, right hand side. Yes, I finished the problem. So technically speaking, you can finish the problem in one line if you're good at it, if you practice enough. But the idea is always the same. Locate things with y prime, move them to the left. Everything else garbage, move them to the right. Factor out y prime, huge brackets, equals right hand side. And the answer follows right away. Y prime equals right hand side over the brackets. Your job is to be careful with negatives. When you move things, it changes the sign. So the first step is the hardest, differentiation, and moving things around, not to mess up the sign. That's not the end yet. Yes?
So what do we do with the 4x squared y prime?
Oh, 4x squared. Derivative of 4x squared is 8x. Plus y is y prime, and then minus 7. So I find derivative, yeah? Implicit differentiation, yeah. Does that make sense? Yes?
Just to be clarified, the review things are just review, not a thing we insert in separately, right?
No, that's just review.
Cool.
Now, after this, what is left to review is whatever we did, the very, very last chapters are left to do. Practice derivatives of log and exponential functions, like in your review 21, 22, 24. So do you remember how to do product rule? Like e to the 5x times ln of x squared plus 3. Not only product rule, but also chain rule. Practice these things, practice quotient rule. Lots of questions like this on the test, which is good because they are not that hard. You just need to practice a lot and don't miss anything. Most of them are multiple choice questions. You finish them, choose it from the list, you're good. Yes?
Do you know how many questions are on there?
Oh yeah, I do actually. And then the last questions are exponential functions, increase, decay, and increase. You need to learn what we reviewed last time. The cup on the table, that was Newton's law of cooling. Increase, don't forget to learn half-life, that is decrease example. And increasing functions, very popular population of the bunnies in the island, expressed by the function blah blah blah. Or the old skeleton was found, 97% of the carbon-14, assume the carbon-14 has a half-life of 5,000. How old is the skeleton? So that is actually a very realistic problem. How do you think they know how old the mummy is? They know based on the chemicals and the half-life of the chemicals. 10 free response, no, 10 multiple choice, and 1, 2, 3, 3 free response. So the same as last time. They are more or less the same. So review that, and that's. I'm kind of which one formula? Law of cooling. Remember everything, but I'm kind of debating if I should put it there or not. So I will decide. But you should try to learn. There's not so many, only 2 formulas. Law of cooling and the weird one with the. Oh, actually, it says we don't have to memorize that one. So that one I will put. But law of cooling kind of makes sense. Outside temperature plus the difference times E. So that I memorize it, and my memory is bad. So that's all. Think about that. This is what we did in months of work. Now your job is to practice hard and get this 90% of 100 on the exam. Come on.